Hello Philscan! Welcome back to Camel's channel! It's me, Milay, with friends!
Just leave me for somebody else. Enjoy yourself, enjoy yourself. Enjoy yourself, enjoy yourself. Enjoy yourself, enjoy yourself.
For today's video, we're going to show you the different types of heat treatment, particularly normalizing, annealing, and case hardening. First things first, do you know what's the opposite of hardening?
Annealing is generally the opposite of hardening. Annealing of steel produces soft, fine-grained, and ductile metal without internal stresses or strains. In the annealed state, steel has its lowest strength. Annealing of steel is accomplished by heating the metal to just above the upper critical point, soaking at the temperature and cooling very slowly in the furnace. Now, if you want to know the critical point or the recommended temperatures for the metals, you can pause the video and search for it. Okay, so now the soaking time is approximately 1 hour per inch of thickness of the material. To produce the maximum softness of the steel, the metal must be cooled very slowly. Slow cooling is obtained by shutting off the heat and allowing the furnace and the metal to cool down together to 900 degrees Fahrenheit or lower. Then removing the metal from the furnace and cooling it in steel air. Another method is to bury the heated material or steel in ashes, sand, or other substances that does not conduct heat readily.
Annealing is a form of heat treatment that softens steels and relieves internal stress. It is heated about 50 degrees Fahrenheit above its critical temperature. Soak for a specified time, then cool. For annealing ferrous metal, having the metal to just above AC3, soaking at that temperature for a definite time, and cooling very slowly in the furnace itself. In the annealed state, steel has the lowest strength. There are 3 annealing processes used in ferrous metal. First, process annealing, commonly used in sheets and wire industries to restore ductility. Second, spherodizing, applied particularly to high-carbon steels to improve their machinability. Third, shop annealing, heating steel in the welding torch 900 degree Fahrenheit to 1000 degree Fahrenheit and dropping it into a pail of ashes or lime to restrict the cooling rate.
How about if we accomplish by heating the steel above the upper critical point and cooling it in steel air?
The normalizing of steel removes the internal stresses set up by heat treating, welding, forming, casting, or machining. Stress, if not controlled, will lead to failure. Because of the better physical properties, aircraft steels are often used in the normalized state, but seldom, if ever, in the annealed state.
To normalize non-ferrous material, it is heated about 100 degree Fahrenheit above its critical temperature, and held there until the metal is uniformly heat-soaked, then removed from the furnace and allowed to cool in steel air. Normalizing is a form of annealing which consists in heating the steel above AC3 and then cooling in steel air. Due to rapid quenching obtained by air cooling, the steel is harder and stronger but less ductile than annealed material. Normalizing is required whenever it is desired to obtain material of uniform physical characteristics.
What if heat treated and the surface responds to hardening while the core toughens?
Case hardening process is a hardware-resistant surface or case over strong, tough core. Case hardening is ideal for parts which require a wear-resistant surface and at the same time must be tough enough internally to withstand the applied loads. The steels best suited to case hardening are the low-carbon and low-alloy steels. If high-carbon steel is case hardened, the hardness penetrates the core and causes brittleness. In case hardening, the surface of the metal is changed chemically by introducing a high carbide and nitride content. The core is unaffected chemically.
The common forms of case hardening are carburizing, cyaniding, and nitriding. Since cyaniding is not used in aircraft work, only carburizing and nitriding are discussed in this section.
Carburizing is a case hardening process in which carbon is added to the surface of low-carbon steel. Thus, a carburized steel has high carbon surface and a low carbon interior. When the carburized steel is heat treated, the case is hardened while the core remains soft and tough.
There are also three methods under this process: pack carburizing, carburizing gas, and liquid carburizing.
A common method of carburizing is called pack carburizing. When carburizing is to be done by this method, the steel parts are packed in a container with charcoal or some other material rich in carbon. The container is then sealed with fire clay, placed in a furnace heated to approximately 1700 degree Fahrenheit, and soaked at the temperature for several hours. As the temperature increases, carbon monoxide gas forms inside the container and, being unable to escape, combines with the gamma iron in the surface of the steel. The depth to which the carbon penetrates depends on the length of the soaking period. For example, when carbon steel is soaked for 8 hours, the carbon penetrates to a depth of about 0.062 inch.
In another method of carburizing, called gas carburizing, is similar to pack carburizing, except the carbon monoxide gas combines with gamma iron and forms a high carbon surface. A material rich in carbon is introduced into the furnace atmosphere. The carburizing atmosphere is produced by the use of various gases or by burning of oil, wood, or other materials. When the steel parts are heated in this atmosphere, carbon monoxide combines with gamma iron to produce practically the same result as those described under the pack carburizing process.
The third method of carburizing is that of liquid carburizing. In this method, the steel is placed in a molten salt bath that contains the chemicals required to produce a case comparable with one resulting from pack or gas carburizing. This produces a high carbon surface when a part is heated in a molten salt bath of sodium cyanide or barium cyanide.
Lastly, under case hardening, we have nitriding.
Nitriding is unlike other case hardening processes in that before nitriding, the part is heat treated to produce definite physical properties. Thus, the parts are hardened and tempered before being nitrided. Most steels can be nitrided, but special alloys are required for best results. These special alloys contain aluminum as one of the alloying elements and are called nitralloys.
In nitriding, the part is placed in a special nitriding furnace. And heated to a temperature of approximately 1000 Fahrenheit. With the part at this temperature, ammonia gas is circulated within the specially constructed furnace chamber. The high temperature cracks the ammonia gas into nitrogen and hydrogen. The ammonia, which does not break down, is caught in a water trap below the regions of the other two gases. The nitrogen reacts with the iron to form nitride. The iron nitride is dispersed in minute particles at the surface and works inward. The depth of penetration depends on the length of the treatment. In nitriding, soaking periods as long as 72 hours are frequently required to produce the desired thickness of case.
Nitriding can be accomplished with a minimum of distortion because of the low temperature at which parts are case hardened and because no quenching is required after the exposure to the ammonia gas.
To recap all the topics we have discussed, the heat treatment processes are annealing, normalizing, case hardening. There are 3 annealing processes used in ferrous metal. First is process annealing, commonly used in sheets and wire industries to restore ductility. Spheroidizing, applied particularly to high carbon steels to improve their machinability. Shop annealing, heating steel in welding torch 900 degrees Fahrenheit to 1000 degrees Fahrenheit and dropping it into a pail of ashes or lime to restrict the cooling rate. There are also forms of case hardening. First is carburizing, second, cyaniding, third is nitriding. For the common methods in carburizing, we have pack carburizing, gas carburizing, and third is liquid carburizing. In this video, we discuss about 3 of the many heat treating processes. These 3 are as different as they come, but let us bear in mind that adding strength to metals is not the only desirable outcome in heat treating metals. Annealing allows metal working to be done. Normalizing helps in returning a metal's properties to desirable values. And case hardening helps make metals wear resistant. Like I said, very different processes, but by now, you should know that they are very important. Being aspiring engineers, it is a must for us to be flexible in our thinking. Just as each component of an aircraft has its own purpose in maintaining its processes, the forming of the materials used for these components is that exactly one procedure.
That's it for today. Hope you've learned something from our discussion.
See you on our